So with the g.c.2.10 notes, instead of looking at angle relationships, we're going to look at segment length properties. Similar to the last notes, we have it broken down into 3 different areas. So the first properties stem from 2 chords intersecting, and really what it comes down to is that part times part equals part times part. So if we look at the diagram, BE and CE that make up chord BC, those parts multiplied equal AE times ED. And this proof is pretty straightforward, so we are going to look at it briefly. We have 2 chords AD and BC drawn in. And if you look at the triangles that are formed with the auxiliary segments, we have vertical angles marked in orange. And then if you look at the angles that I've marked with circles, they both intercept the same arc, so they're going to be congruent. And so by angle, the triangles are similar. And then if we have similar triangles, we know corresponding parts are either going to be proportional for sides or congruent for angles. We want the corresponding parts, sides are proportional. And from there, we can cross multiply to get the statement that the part times part equals part times part. It's pretty neat and concise. And so you have a few examples worked out for you. Looking at trying some on our own, we have 3 times 2 is going to equal x times 4 since 2 chords intersect. So 4x equals 6. X then equals 1.5 centimeters. Super quick. Looking at this next example here, if you read the diagram properly, we have 7 is the radius of the circle, if you will. 2 is this little segment right here, which means that 5 is this bigger segment. So looking at part times part, we have 5 times 9 is going to make up 1 chord, and then 6 times x. So 5 times 9 equals 6x. If I divide 45 by 6, I'll get 15 halves, for example, or just 7.5 centimeters is also fine. And looking at the last one here, we have these congruence marks. So 6 and 6 make up the 1 chord, 5 and x make up the other. So 6 times 6 equals 5x, 36 equals 5x. If we divide both sides by 5, we'll get 7 1/5 or 7.2 centimeters for x. The last 2 theorems with regards to segment properties discuss 2 secants intersecting and forming segments, or a secant-tangent relationship forming segments. And here it's very similar to altitude to hypotenuse, where we were looking at part times whole in similar triangles. And here, when we have 2 secant segments, EC, the outside part of segment EA or secant EA, times the whole segment EA or secant segment EA equals ED, the external part of the other secant, times the entire secant segment. So you could say part times whole equals part times whole as long as you understand the part that you're looking at is the external part. The other relationship that we have from a secant-tangent relationship is that, similar to above, the external part, AB, for example, the diagram, times the whole, AC, is equal to, since we only have one part here with the tangent segment, it's just part times part, or AD squared, like the whole segment. And there are proofs pretty similar to the first proof we looked at, but in the interest of time, I'd like to go ahead and jump into the applications. There are some examples that are worked out for you. So here we have a secant-secant relationship, since they both extend from and through parts of the circle, so from a point outside the circle through the circle at 2 different points. And so here we have that the part 2 on the top segment times the whole, 2 plus x, equals the outside part of the second segment times the whole, which is 6.5. From here, we could go ahead and simplify, just kind of distributing and cleaning it up. We get 4 plus 2x equals 19.5. Subtracting 4, we get 15.5 equals 2x. And if we divide both sides by 2, we get 7.75 centimeters for the x. Looking at example B, we have another secant-secant relationship, and here, just keep track of all the parts. So we have the outside part 4 times the whole is going to be 12 equals 6, the outside part of the other secant segment, times the whole, which will be 6 plus x. If we go ahead and clean this up some, we get 48 equals 36 plus 6x. Subtract 36 from both sides, we get 12 equals 6x. Divide by 6, and we get x equals 2 centimeters. And in the last example here, we have a tangent-secant relationship. So the only part we can multiply by itself is 12 squared, and that's going to equal 5, the external part, times the entire segment, 5 plus x. And if we go ahead and simplify, we get 144 equals 25 plus 5x. Subtract 25 from both sides, we get 119 equals 5x. And if you divide 5 into 119, we do get 23.8 centimeters.